Hello and welcome to my video 1.4 on the volume or capacity of spheres, cones, and pyramids. So first of all, here we have a sphere, and this one, there is a way to learn why this formula is the way it is, but it has to do with calculus and integration, and therefore don't worry about it. I'm not going to tell you how to get there. You guys don't have to know how to get there. All you have to do is know how to use this formula. You are given this formula on the formula sheet, so all you have to do is know how to use it. So let's say we are given let's pull out a calculator because I'm going to need that in a second. Let's say we're given a sphere of radius, so r equals 3. So what can we do if r equals 3? Well, we can just plug it into our equation. So volume equals 4 over 3 pi r, which is 3 cubed. So 3 cubed is 27. So actually, let's write that down on the next level. Oops. 4 over 3 pi times 27. 27. Now keep in mind that was a 3, so we can actually simplify this a little bit, and we can get to 4 times 9. So one of the 3's from this cubed is being cancelled over here. So that's just me doing the calculations in my head. Pi, and then we are left with 36 pi, which if you type it into your calculator, you would end up with 113. We'll leave it there. 113. So if this is centimeters, then you'd have to have centimeters cubed. So that's all there is to a sphere. Now the trick might come when you have, well, let's say half a sphere. So half a sphere, you'd normally call a hemisphere. Well, what do you think you would do? We would just divide it by half. So if this was a sphere of radius 3, so this is r again here, all you would do is have half of this. So divide by 2. So our answer would be now 56.5, so 57 centimeters cubed. So that's all there is to it. So if you have a sphere, this is the formula. If you have half a sphere, this is the formula, you just divide by 2. If you have a quarter of a sphere, this is the formula, you divide by 4. That's all it is. Alrighty, let's go down to a cone. And a cone, actually, let's show both a cone and a pyramid, because they're both the same sort of idea here. Cone and a pyramid is this formula. Volume equals 1/3 base times by height. That is the formula for both a cone and a pyramid. Now, for a cone, the base is this circle here, right? It goes around like that. And the circle has pi r squared as its formula to get the area of the base, and then times by the height. Okay, whereas a pyramid has a square base, like that, going around the square. And so that would be length times width, right here. So they're basically the same formula. It's just 1/3 base times height. Now these formulas will show up on your, or this formula will show up on your formula sheet, as well as this formula, as well as this formula. So you may have to put things together, but this is the idea here. Okay, so what if we could have a slightly more complicated situation where maybe you're not given the height. Maybe you're given the radius, which I'm going to say is 2. Let's actually make that 4. And let's make the side length 5. Now the side length doesn't actually give us the answer here. Actually, let's use a different color. Let's use green. Okay. 4 and 5. Okay, so our side length doesn't actually give us 3 and 5. Yeah, that will make it make more sense. So our side length isn't our height. Our height is from tip, this apex is what we call it, to the center of our circle. So that's our height. Side length is along the edges. So let's do some calculations here. Keep in mind now that if we don't know h, we can't plug it into our formula yet. We might need Pythagorean theorem. So let's pull it off to the side here. So if we have 5, we have 3, and we have an unknown. I almost gave it away. H as our unknown, right? Then we can use Pythagoras theorem. So I gave you guys all these options here. On the formula sheet, it will only give you this top one. C squared equals A squared plus B squared. Okay? From that, I'm getting to our next step, which is to show S, our side squared, equals our height squared, plus our radius squared. So I'm just showing it with these letters, and then the actual useful ones will be these two bottom ones. So you might have to rearrange to get there, which all you're doing here is you're taking this and you're subtracting it over to the other side. Or you're taking this and you're subtracting it over to the other side. That's all it is. So in this case, we want to get to h, because h is our unknown. So let's just show it here. S2 equals h2 plus r2. Well, if we want to get h by itself, then we want to move r to the other side because we know what r is. So what we want to do is have a minus r squared on this side and a minus r squared on this side. So then we'll be left with s squared minus r squared equals h squared. Okay, now that we have this, we can go one more step and use square roots on both sides. So square root cancels out this part, this 2 here, right? So square root will cancel out the squared, and these squareds will not cancel. So let's now put in our numbers and see what we get. So we have a square root of s is 5 squared and r is 3 squared. So now we're going to have to simplify that to find some answers. So 25 minus 9 is 16, and the square root of 16 is 4. So h equals 4. So now that you have calculated the h, let's just circle that and bring it over. Whoop. Now that we calculated the h, now we can plug it into our formula. So v equals 1/3 pi r, which is 3 squared, times by h, which is 4 in this case. All right, so we just found h in order to get there. So now we can just multiply through and get to our answer. So keep in mind that we have a 3 and a 3, so one of those is going to cancel. So we're going to have 3 times 4, so 12 pi. And then if you plug that into your calculator, you get 37.7. Let's say it's centimeters cubed. I'm never good at the units anyways. Should be. I will tell you about those, why they're so important. But units matter, okay? But I sometimes forget to write them in, because I'm lazy, and that's bad. Do as I say, not as I do. Okay, let's move on to volume of a pyramid. So it's the same thing again, base times height, but you might have to do something else in order to get to the Pythagoras step. So maybe you're given the side length again. Okay, we'll call it S by the W. So if you're given the W and the L, so let's say this is 2, and let's say this is 4, okay, then what you have to do is imagine to get that triangle, right? In order to work at our height. So let's actually use this 3 here. Okay. So you'll have to kind of imagine to get that triangle, but let's see if I can help you imagine it. So height goes down like this, goes like this, and like this. So now we have a triangle. And the 3 sides of our triangle have height on this side, have 3 on this side for the side, and the other side is not actually our length. it's half of our length. So if I brought this across, it would be half of our length. So it's half of our length. 1/2 L. Okay, that's very key, and that may stump some of you. So keep that in mind. So now that we have that, we might have to work our way to calculating. So, okay, h equals the square root. So I'm just going to skip a couple steps from before. Square root of 3 squared minus 1/2 of 4 is 2 squared. So now we need to go another step. So we have 9 minus 4 is 5. So square root of 5. And that's as simple as we can go besides getting the actual number, which I will tell you, but it's better just to leave it as square root of 5. Okay, and it keeps going. Okay, because it's irrational. Okay, so square root of 5 is the height. All right, so let's plug this into our formula. So 1/3, L is 4. Width is, or W is 2. Height is square root of 5. Okay, let's just plug that into our calculator because nothing simplifies helpfully here. Divide by 3. So we plug that into our calculator and we get 5.96. And there's more numbers afterwards. Okay, so again, centimeters cubed, let's say. I'm better if the question's already there. I will always have the units at the end. Anyways, so that's how you get the volume of a pyramid. So it depends on what numbers you're given. But if you're given one of the sides, Pythagorean Theorem is very, very key. And keep in mind that if you're getting the other two sides, then you can always use this subtraction sort of step instead of the addition. I hope this video helps you understand the volume and capacity of spheres, cones, and pyramids. Good luck!